Hi, and welcome to freenetworkstudy.com. In this ospf lab, we'll be looking at ospf broadcast and ospf non-broadcast network types. Since both these types support designated router election, they would be compatible, and as we're about to see, this compatibility would require a little configuration. So let's just get started and jump back to the requirements list when needed. On router 1, show IP protocols. So ospf is not running. Router ospf 1, enable ospf on the interfaces, network 10.1.1.0/24 in area 0, and network 1.1.1.0/24 still in area 0, and finally network 11.11.11.0/24. Now we're told to configure router 1 serial interface with the network type broadcast. So under interface serial 0/0, apply the IP ospf network broadcast command. Let's verify how this configuration looks like so far. And that looks pretty good. Now let's jump to router 2. Show IP protocols. ospf is not running. Router ospf 1. We're told to use only one network command on router 2 and 3, so that's the network 0.0.0/0 0.0.0/0. We're also told to make sure that router 2 and 3 are never elected designated routers on this segment. We can do that by telling the interface not to be candidate in the election. So interface serial 0/0 and IP ospf priority 0. Now let's configure router 3. Show IP protocols. ospf is not running. Let's configure it. Router ospf 1 network 0.0.0.0/0 area 0. Now let's configure serial 0/0 to never be a candidate in the designated router election. Interface serial 0/0 IP ospf priority 0. Okay, so we're done, but we haven't noticed that any neighborship went up. Let's have a look at our neighborship so far. Show IP ospf neighbors. Notice that router 3 doesn't have any neighbors. Let's just look at the show IP ospf interface serial 0/0. Okay, so the interface is up. It is running ospf, network type non-broadcast, and its hello and dead timers are 30 and 120. Now let's compare this to router 1. Show IP ospf interface serial 0/0. Okay, on this side we notice that the network type is broadcast, which is expected since we've configured it to be that way, but we also see that the hello and dead timers are 10 and 40, which is not matching the other end. And remember from the courses that matching hello and dead timers are a requirement to set up a neighborship. So let's go ahead and modify those timers so that they match. Configure terminal, interface serial 0/0. The timers on router 3 were 30 for hello and 120 for dead. So let's make sure that router 1 matches those timers. To modify the ospf timers, use the IP ospf hello interval, and 30 to match the other end. You don't have to match the dead timer because this is automatically set to 4 times the hello timer. Now we see that we have full neighborships with the other two routers. Let's have a look at these neighborships. Show IP ospf neighbors. We see that we have full neighborship with router 2 and router 3. We also see that they are other. In other words, they are not designated router or backup designated router. Now we have one last requirement, is to make sure that all loopback interfaces are advertised with the correct mask of /24. First, let's confirm that this is not currently the case. Show IP route ospf, and we see that all loopbacks advertised with a /32 mask. And this is due to the nature of the ospf loopback network type. To fix the issue, we would have to change the network type to point-to-point. And for those of you who wonder why not another network type, such as broadcast or non-broadcast, the answer is it would be a waste of resources to create a pseudo node related to the election of a designated router on a loopback interface. So let's go ahead and change the network types to point-to-point on all loopback interfaces. Configure terminal, interface loopback 0, IP ospf network point-to-point. Same thing on loopback 1. Now on router 2, interface loopback 0, IP ospf network point-to-point. Back 1. And now on router 3, interface loopback 0, IP ospf network point-to-point. And on loopback 1. Now let's jump back on router 1 and check the IP routes. Now all loopback subnets advertise with their configured /24 mask. Finally, to test end-to-end IP connectivity, let's jump on any of the spokes. So on router 2, for example, let's ping router 3's loopback interface, ping 3.3.3.3. And that's working. Thank you very much for watching.